welcome everybody. I'm Kyle Baxter. I'm going to be talking about how you design your AI ML fabric with Abstra. And so many of you aware probably challenges that are out there. The AI space is moving so fast that there's a demand to deploy it now. And the challenge is it's the network, the industry is moving so fast that there's not enough adequate trained resources out there. And when they are, there's hundreds and hundreds of pages of this documentation, how to configure this or that or this protocol. And there's no time to read up on that, become an expert. And that's where Abstra can come play and be your expert assistance to help you deploy. And so when we're talking about deploying, we're going to be looking at Rail optimized designs. We've covered this in some of the other sessions on why Rail optimized designs. This came from NVIDIA designs to make the most out of the network, to get the most throughput, reduce latency, reduce congestion, all of that, get all those benefits. But when designing it, how many of you could design it and say, give me a design and give me a cable map right now? Right? But with Abstra, I can show you how to do it in 5 minutes or less. Who wants that? Yes.
I do.
And so we start with a simple template designer where with just a few basic inputs that imagine as an architect, you're looking at this, you're probably going to know all these. You're going to know how many servers I want to use, how many GPUs per server. It's going to be 8, but maybe you don't want to use all. But that is configurable. How many servers per stripe? What is your GPU NIC speed? What is your oversubscription ratio on? So pretty simple things that any architect will know, and they can put this in the input, and it will tell them exactly what are your design options based on those inputs. And it could be different things. You can see there's some that are using PTX 10K16s as leafs, or do you want a QFX 5240? It gives you options that say, depending on what devices you want to use, or how many of them want. You can see some of them can be different quantities potentially. And so you can pick the devices that make the sense for you, that match your design. And you can preview that to see what is that going to look like, how is that all going to be connected, so they can say, yep, that makes sense, that's the template design I want to use. And then once you save that design, you can have a list of saved designs. You can see I have different designs. I have a 1,000 GPU, a 4,000 GPU, an 8,000 GPU, some collapsed fabric that are smaller, like 128 GPUs. I have different designs that I want to use that I can then take those in seconds. I can deploy them and have them ready to go. So it only takes me just a few minutes to design it and deploy it. But then what do you need to do next? Now what? Like, that's great, you built me a template. You pick the devices I need, that's great. But what's next? Well, the next thing you're probably going to want to do is you're going to want to have a cabling map to know how to connect all these things. Because there's a lot of connections. When you're talking about, like a 4,000 GPU cluster, there's a lot of connections. And so what we can do in Abstra is even before you have hardware that shows up, before you've ordered anything, you can build that design in Abstra without the hardware, where you can have that cabling map and you can see what it is. You can export it, whether you want it in JSON or CSV, not CVS, CSV, depending on how you want to use it. And obviously it's going to be a big table because it's a lot of things, but it allows you to take that cabling map and then give it to whoever's going to be plugging in the hardware when it arrives. So you have that full design. But even if somebody goes and doesn't plug it in exactly right, even afterwards, once it is connected, we can use LLDP to see, did it actually get plugged in the way it was intended? Because that's the whole intent-based networking design we have in Abstra, is we validate and continuously validate that the running network is operating as intended, including cabling map, including config drift. All those things we can validate and continuously validate, so we can make sure that cabling map's right.
Will you also put up a picture of the switch and highlight the port and say this one's wrong?
Yes.
Thank you.
Yes, we do that. We have the cabling mapping, and we can show exactly which ones are wrong, and show the mapping of, hey, this spine to this leaf, or this leaf to these GPU servers. We can map all that and show all that. Absolutely.
Excellent.
Yeah, great question. And so that cabling map is really nice as well, but the other thing we can do is we can look at the configuration. For those that still love looking at CLI and don't trust that automation is going to deploy what they expect, you can go look at the CLI, and you can go look at the config and see everything that is generated. And then back to our multi-vendor point is we can generate for multi-vendors. So not only just Cisco, but we can generate it for other vendors as well, including Cisco and Arista and Sonic-based devices. We can cover those. And so it allows you to see the cabling map, see the configuration, all before you ever ordered a single piece of hardware. So let's see a little demo of this. So I'm going to show you here in just a couple minutes how we take an input on how many GPUs we have, build a template, deploy that template, get the cabling map, and we're done. I mean, that's amazing. We can do that in 5 minutes. So let me go over here, and I'm going to play a little video so that way we can walk through it. So I'm going to go to Abstra. I'm going to go to templates, and there's a create an AI cluster template. And so just like we talked about earlier, I can have inputs and automatically updating on the top. You saw the number of GPUs automatically changed as I added different settings. And then I can see in here the different combinations. So again, you can see some different combinations of if I want to use one of the PTX chassis, I can reduce the number of devices. But if I don't want to buy a chassis, I could buy a 5240 from the QFX line and have those.
Question.
Yes.
Brian Martin, Signal 65. You have servers per stripe. What's a stripe?
So simply, a stripe is a collection of rails. Okay. So it's how many do you want in that stripe to make it up? Because that rail is a single combination of all the GPUs connected, and then a stripe is a combination of the rails.
Okay, so that's basically the number of ports that'll be used for a given rail. How wide we go with the servers?
Yes.
Okay, thank you.
Yeah, excellent. Thank you, Brian. So now that when I decide I want to use all 5240s, I don't want to use a PTX for whatever reason, and maybe I don't want to buy a chassis, I can look and see here, and I can hover over and see how everything's all connected. It's a lot of connections because we're talking about 1,000 GPUs. So there's a bunch of servers in there that are connected, but we can see how it's all connected. We can see then here the number of spines, the number of rack types we have. We can see the devices it's picked. It's 5240s as we expected. So then I'll save it, give it a name, and we'll save that template. So that way we can use this to rubber stamp and just repeat the design over and over if I wanted to. And so we had that design saved. So now I'm going to go to my blueprints. And in Apstra terminology, a blueprint is your design of what you want your data center to look like. So just like a blueprint of your house is the model of your house looks and gives you all the specs, a blueprint here in the data center is a blueprint of how you want your fabric to look and operate. So I'm going to give it a name, and I'll pick my template. So like I said, in just a few clicks, we can deploy that template, and look, it looks exactly like what we had in the template. No surprise. So it matches exactly what we built in our template. And we can now go quickly in just a simple button, create, and it's going to go scaffold that whole design for us. It's going to use some default pools of like IP addresses and ASNs. You can configure that to however you want, but it defaults to some default pools, so that way you have something to start with. And then we can go right into our staged area, because in Apstra terminology, we have the concept of staged and active. As the names indicate, active is what you actually have deployed. It's what's active. Stage is where you can play with the design, see what it's going to look like. And this is where we can look at things like the cabling map and the configuration, all before we even ever have a single piece of hardware. And so we'll then look at the links. We can see the cabling map. We can then export it like we already saw and talked about into CVS or JSON files. We can see exactly what interfaces everything is connected on, what IP addresses they'd be used. So it gives basically an exact blueprint here that we built in just 5 minutes and say, hey, I'm already ready for building 1,000 GPU server. Here's the cabling map. When you're ready to order the hardware, order it, plug it in as I specified, and it's just going to work.
So question on the backing up a second.
Yeah, please.
Have I already made some decisions on the racks and all of the DGX systems that I need in this particular fabric, right? Because if this is from the network operator perspective,
Yeah.
how have I ingested what systems I'm going to use in this fabric? Or are you saying I build the fabric before I decide what DGX systems I'm going to plug into it? Where's the deciding factor of how I build the fabric?
Mm-hmm. So we're focused more on the networking side, obviously, or networking company, but we do model also, and we do have agents that live on the GPU servers, and that's how when we get to it, we'll show some of the metrics we get on the NIC and the GPU, and we can monitor that. So we model it as what we call like a generic system. So that way, it's anything that can fit that kind of idea, which needs to be some kind of, it's like all of them are like Ubuntu servers. So the agent lives on that Ubuntu server, and we can then connect to it. So really, what you're looking for is what is the NIC speed that you need to get there. Beyond that, whatever DGX server you have or GPU server you have is transparent to that process.
So there's some sort of management plane connectivity, right, to those systems that I'm ingesting here. So I've got it like a data feed perspective.
Yeah. So when you actually get the hardware, you need to then assign it in Abstra and say, hey, this for like the switches, this serial number matches this leaf that I want to use.
Corresponds to this.
Yeah. And then the same thing with the GPU servers. You correspond, hey, this one goes to this location in that template design. So there is obviously some assignment that you have to
I've got the GPU operator design as well that would kind of mirror. Okay. Perfect. Thank you.
Yeah, no, good question.
So while you're configuring, are you also then choosing which of those many load balancing techniques we just learned about? Or does it automatically default to the RDMA aware one? Or what?
Yes, we do. And we'll get definitely more into that. But yes, we do have load balancing configuration. So this first section was really all about how you get the initial design built and then to a cabling map and be able to see the config. So that way you're ready to order and start plugging in. We'll get right into in the next session on how we do things like load balancing and how we do assigning virtual networks, all those things to actually get into some of the what we call like the day one, where you're starting to get into not just the design, but into kind of more in the deployment phase.
You mentioned, so go ahead.
Tim Sprinsky, CDC. Just curious, we're here basically looking, right, GPUs are the problem in this situation, right? But are we also going to take a look at, well, I've got this database server I've got to plug in. I've got storage. I've got other, possibly a public network that I need to plug in. Does Abstra also handle, say, security aspects, and things like that?
Yes. So back to my point earlier, for no matter what kind of network it is, we can manage it. We're focused a lot today because it's AI Infra Field Day on how we would deploy the back end training. Right. That's what's new, but we've been doing it for years of any other kind of network, like you said, storage network, or even a front end inference network, which follows a more traditional design. Gotcha. That's not not always the rail optimized kinds of designs. So absolutely we can do that, and you can use it in the same single Abstra instance. You can have multiple blueprints for like your back end, your front end, your storage, and so you have, and then you can move around just in your single UI and be able to see that, and even do things like data center interconnects when that's necessary.
That was my next question.
Yeah. And then on your point on security, we have security policies that can limit, what do you want to talk to what or not talk to what? And then we can even look at flow data to see, is there potentially something that's deviating or looks malicious inside the network? So we talked a lot in the past session about, how do we, prevent some of that stuff, going in and out of the network. Okay. But in the network, we can look at east-west traffic and to see, is there potentially something malicious going on, to inspect that by looking at some of the flow data, like S-flow packets and things like that.
Got it. Okay.
Does this take into account the specific type of NIC you're using, or what your interfaces are going to be, or is that just assumed that you know what that is?
It does take into account some. We're not doing NIC configuration at the moment. So we're more looking at getting metrics and information from the NIC, so we can look at things like congestion and out of sequence, and then also the health of the general server. NIC configuration is something we're looking at in the future
Okay.
that we can get to. So in that, when it gets to configuration, yes, then that would obviously matter what kind of NIC it is. But when we're looking at all the NVIDIA GPUs, which is the big play in the space, we can get all the common GPU metrics and NIC metrics from the NVIDIA servers.
Okay, and the second question along those lines is, if you're coming up with a cabling diagram, if you actually know the layout of your data center, can you also come up with cable lengths out of the configuration?
We don't look at cable lengths.
If you have a cabling diagram,
Yes.
the next question you have is, what are the lengths of the cables?
Yes. That's a very valid question. We don't have that yet in the product for like cable lengths. But we have like what should plug into what, interface this on this and this interface on that one. But that's a great question, because obviously you're going to need to look at how far cable lengths, especially when you start getting into some of these high speed ones, that cable lengths can make a difference.
Okay, well, I figured it would be like the next progression of what of the information you have would be, show me how the data center is laid out.
Mm-hmm. Yeah. I mean, we can show it from like the physical connections of what's connected, like I said, but not the cable links yet. I think there was another question, or a couple over here that.
Yeah. So, quick question. So, you mentioned that it sits on top of Ubuntu, or you can connect to Ubuntu. Do you need to have versions for Red Hat and for SUSE and for all sorts of things?
Our agent is agnostic to
That's all
the
under the
Linux
covers
version.
for you.
Yeah.
Okay, you just mentioned Ubuntu servers because that's what you're using.
Because I mean, Ubuntu's typically what a lot of the NVIDIA GPUs or servers are running, and I think they're all on Ubuntu at the moment. But our agent is agnostic to any Linux version. It can be deployed on others.
Thanks.
Okay, I didn't get something like after you stage the design, there visualization process of what is connected at. So probably partially the answer.
It's okay.
Yeah. If is there any validation process or after stage?
Yes. So we do lots of validation. I'm actually going to show it in the next one on how we catch errors, because the first one I'm going to show is how we catch errors of things that were like virtual networks aren't assigned.
Okay.
And so we'll see some of that in how we have validation in our stage before we push it to the active, to that production, and we prevent you from pushing bad code to your production network.
Yeah. Gotcha.
But yes, we do all that validation. We can also do commit checks. So if you're familiar with the Junos CLI, you can do commit checks on Junos commands. We can help you run all that on the staged area before you deploy it.
Okay.
So in addition to other validations that we can do things like commit checks and validate syntax and all of that.
Okay. Got it.
Yeah. You got another one?
What's under the rack tab? The racks tab.
The
That-
racks tab.
Is that where we figure out how many servers per rack?
Yes.
Per rack? Okay.
Yes.
Good.
Exactly.
So we can map it out physically.
Yes. Yeah.
Great.
Yeah. We can map it out physically, just not the cable links.
Yet.
Yeah.
Yet.
Okay. All right. So, a couple more things that I wanted to point out that we got to. What if I need some more flexibility? A common one we get asked on is, what if my server count's low enough that I don't want to have, or I don't want to have multiple stripes, and I want to do everything in one stripe. So meaning having leaves only and no spines. So then everything connects and runs through those leaves and the NVLink on the NVIDIA side. And we can do that as well. So we can build that in the template designer, where you can have 128 GPU servers to get to 1,000 GPUs, but only have 8 leaves. And then you don't have to have the spine layer on top for additional connectivity. So it saves you some on hardware cost, optics cost, all those things. So if you have a small deployment, we can do things like that to give you that kind of flexibility, kind of like a collapsed fabric in a way, where we're collapsing everything in and reducing from a 3-stage to a single layer.
Would that be the collapsed rail design? Click button there.
Yes.
So you have L3 Clos and collapsed rail, no straight rail or rail optimized, or is that what Clos is rail?
Clos is rail.
Okay.
Yeah.
So no straight Clos
Yes.
in the solution. Okay.
Yeah.
Thanks.
And then this gets back to the other point we're talking about, is what if, you know, a lot of people ask, what if I want to do something else with my, you know, my front end, my storage network, all this. So, you know, we can do your typical designs that, you know, aren't the, you know, the rail optimized that we're talking a lot about today. So we've had that in the product for years. So I just want to make sure we cover that. So any kind of network design you want to do, whether it's rail optimized or not, we can do that as well. So to summarize, what we've seen is Abstra can be your expert to help you deploy faster. We saw how we could deploy, you know, from specs to design to cabling map in a matter of minutes. And we were able to do that all without having a single piece of hardware, where we could look at how the cabling map, how the config's all going to look. We can validate all that before the hardware arrives. So we know that when the hardware arrives, we're ready to go, plug it in, and let's start using the equipment and start building some exciting models. So any final questions on this section?
I had one. Karen
Yeah.
Lopez, Info Advisors. So you mentioned, I picked up on, you mentioned you're doing all this in a contextual graph database.
Yes.
And is that something you've developed yourselves? Are you leveraging another product or?
No, it's proprietary. We built within Juniper.
And perfect, thank you.
Yeah.
And I might have missed this, but what type of APIs and SDKs are needed for this? And if so, do you have?
So we have full REST-based APIs. We also have Python SDKs. So whatever you want to build, we have a lot of people that are doing integrations. We also have a Terraform provider that's becoming very popular in kind of the networking world to simplify and make managing private clouds very similar to how you would manage public clouds. But then you have the advantage of it's your private cloud, it's your infrastructure, but you have the same kind of operating capabilities. We actually demoed that at a previous field day session. So anybody that wants to go look at how Terraform works, we've done that before as well. Or you can just simply, you know, search for Juniper Apstra Terraform, and you'll see the Terraform module out there and all the documentation out there with it.
And Ansible support, is that coming?
Yes. Oh, yes.
Okay.
We do have Ansible support as
Okay.
well.
All right.
So thank you for bringing that up. We do have
appreciate
Ansible support as well for those that still want to use that. All right.
One more question, Bart Jungens, Bitcoin. In the beginning, you mentioned that there are typically 3 networks. There is the storage network, the front-end network, and then the GPU network.
Yes.
When we see all this now in that blueprint, is everything connected to the same switches, or are these dedicated, separate networks? So the GPU has their own dedicated switches, or are those 3 networks all combined, converged on the same switches?
They're typically running on different switches, different networks, but there is sometimes connections between them, or they're sharing potentially GPU resources. But they're thought of and modeled within Apstra as separate networks, separate switches.
Okay. And so Abstra is also aware of this, of these 3 different networks then?
Yes.
Okay, thanks.